In this video, I will show you the basic concept of a linked list. For this, we will go to File and then Open. And from chapter number 17, there are a number of programs, and we will select this. First of all, linked list type. And open this folder, and there is only one header file in this, that is LinkedList.h. Alright, this class will be used as a base class in other programs. So we will understand this class first of all because it will be used as a reference in other projects. So first of all, you can see that here we are using templates. We use templates for creating generic types. Okay, generic types are those types which can be used for different data types like integer, float. We have already discussed this concept in the previous lectures. Then first of all, we have a structure. Its name is node type, and it has two members, info and link. And as we can see that this is basically represents a node of the linked list. A linked list node consists of two parts. First part is info part that contains the data of the node, and second part is the link pointer that points to the next node of the list. So the data type of info is generic type. It means the node can be of any type like int, like float, or even of any class type. And the data type of link pointer is basically node type of selected type. Okay. Then we have a linked list iterator class, but before this we will examine another class, and that is linked list. Okay, I have collapsed all these definitions. We will discuss this class and its functions later. First we will discuss linked list type. It also implements template. It means we can create a list of any data type, like it can be a integer linked list, it can be a float, it can be an object of any other class. So what does this class has? First of all, it has overloaded the assignment operator. The assignment operator is used to assign an object from right hand side of the assignment operator to the object on the left hand side. So we will discuss its implementation. How is this implemented? Then there is a function initialize list. What does this do? It simply initializes the list to an empty state. It simply sets its first and last variables to null pointer, and count variable is equal to 0. Before discussing these function definitions, let's see its members first. So these are the members. First member is count. As its name implies, it will hold the total number of nodes in the list. Second member is first, that is type of node type, and third one is last. First member points to the first node in the list, and the last member points to the last node of the list. And there is a private member, that is copy list. This is basically a function. It is used to make a copy from a past object in the parameters list from other list. Now let us see its. These are the main three members of the linked list, and and these members are protected members. It means they can be used in the child classes. Okay, now we will discuss the its functions. We have already discussed this overloading of assignment operator, and then we have initialize list. I have already talked about this, and then this function is empty list. What does this function do? It simply returns true if the list is empty, and otherwise it returns false. Print function, as its name implies, it prints outputs the list elements. Length function, it returns the number of nodes in the list. So basically this function will return the value of count variable. Destroy list, this function will delete all the nodes from the list and set first and last equal to null pointer and count equal to 0. Then next function is front. What does this do? It returns the first element of the list. Okay, and back, it returns the last element of the list. Search, it finds a given item in the list and returns true if it is found in the list, otherwise false if it is not found. Insert first, this function inserts a new node at the start of the list, at the beginning of the list. And insert last, this function inserts a new node at the end of the list. Delete node, this function will simply receive an item to be deleted, and then it will delete the given node from the list. Then there is a function begin, and what it does, it returns an object of iterator class. Before discussing begin and end functions, let us see what is about iterator class. This is iterator class. Okay, as its name implies, this class is used to iterate through the objects of the linked list. It provides an iterator object through which we can iterate through all the elements of the linked list. So what does it have? First of all, let's see its members. It has a default constructor. It has a parameterized constructor which accepts an object reference to a node type object, and then there is an overload operator overloading. What operator overloading? Dereferencing operator, static overloading. So it simply returns the value in the info part of the node. And then there is a operator overloading of increment operator, pre-increment operator. It returns the iterator object pointed to the next node in the list. Then we have operator overloading of equality operator. What it does, it returns if the past object of the iterator is equal to the iterator object on which this function is being called. And then we have not equal to, that returns true if the past parameter is not equal to the calling object, otherwise returns false. Then it has a current member, private member. So this class is basically used to provide an object through which we can iterate through which we can visit each element of the linked list. So here are its definitions. This is default constructor in which current is assigned a null pointer value. Then this is the parameterized constructor in which ptr which normally starts the which normally points to the starting node of the list, and this ptr is assigned to the current member. Then we have next a dereferencing operator overloaded, and it simply returns the current node info part. And then we have next is increment operator. What it does, it points it makes the iterator object point to the next node. So simply it the current node points to the next node link. It simply gets the next node and assign to the current node. And then we have next is equality operator, and it simply compares the current object with the past object's current pointer and returns the true or false. Similarly, the not equal to operator. This we are discussing begin function. What it does, it returns the first node of the list and returns its object of linked list iterator. And then we have end. It returns the last element list of the list and returns its iterator object. These functions facilitate to provide iteration on the linked list. And then we have default constructor, and then we have copy constructor and destructor. So let us see now the definitions of its functions. First of all, we have is empty list. It simply checks the value of the first node, and if it is null pointer, then it returns it to true, otherwise false. And similarly, next is the constructor. It's in constructor, it simply assigns null pointers to the first and last nodes and assigns count to 0, assign 0 to count. And then destroy list. In destroy list, what is being done, in this function, all the nodes of the linked list will be deleted from the memory, and then first and last pointers will be assigned null pointer and then assign count equal to 0. Okay, you can see here we have created a temporary node, and then we are running a loop while first is not equal to null pointer. You know that first basically is a pointer that points to the first node of the list. So we will start the loop from the first node of the list and assign first node to the temporary node, and then we will shift the first node to the next node by assigning the first link to the first node. In this statement, the first pointer will start to point to the next node, and in the meantime, the first node which we have assigned to the temporary node, we will delete this from the memory. So in this way, in this loop, we will visit each element of the linked list and we will delete every element, and at the end we will assign null pointer to the last and 0 to count. And then in initialize list function, we have called this destroy list function to delete all the elements and initialize the list. And then we have a print function. In the print function, simply we have used another object, another node, that is current. We have assigned the value of first to the current, and then we have make a loop running on all the elements of the linked list by applying this condition while current is not equal to null pointer. and this loop will run from the first node to the last node of the list, and it will print every current node's info part, and it will then shift the current node to the next node. Then we have length function. It will simply return the value of count variable. Then front, it simply returns the value of first node. Okay, but before that it uses assert function. Assert function, what it does, it simply compares, it simply evaluates this condition. If first is not equal to null pointer, it means the list is not empty, then it will simply returns true and the program will continue its normal functioning. However, if this condition becomes false, it means the list is empty, then this function will return false and the program will terminate. And simply this function returns the data in the last node, and it also asserts, it also checks whether last node exists or not. And then this begun function, which is providing facilitation in iteration of the linked list, and it simply passes the first object, first node to the to a new object of linked list iterator class. Its name is temp. It simply creates a new object of linked list iterator class. The name of that object is temp, and it passes the first node to this object and then returns the temp. So this temporary object will facilitate us to move through the all elements of the list. Similarly, the end function performs the same, but it passes the null pointer to the an object of linked list iterator. And then we have a copy list function, which what it does, it simply receives an object from other list past parameter and creates a new object from this other list. So what this does,